All right, I'm going to show you how to solve or perform operations with functions. And for the examples that I'm going to use here, I'm going to use f of x and g of x. You could use any other letters. I mean, you'll see examples with other letters. Typically, this is what we use is f of x and g of x. And do not be confused if you see h of n or m of s. I mean, not that that happens a lot, but you're just going to treat them the same way, okay? So in the examples I'm going to show you today for all of them, f of x is equal to 3x plus 1 and g of x is equal to 2x. Again, this can change from problem to problem, but these are just the examples that I'm going to use today. Okay. Now, the tricky part about function notation is just understanding what it means. So let's say you see f of x plus g of x. Well, this is the same thing as saying f plus g of x. I prefer this way. This is the way that I personally prefer to see it written. However, you are going to see it this way, and I just want you to realize that they mean the same thing. Okay, so what this means is you're going to actually take the function f of x, which is 3x plus 1, and you're going to add it to the function g of x, which is 2x. So that means we are going to say that 3x plus 1 plus 2x. Okay, so this is f of x, that's the 3x plus 1, and then we're going to add it to the g of x, which is simply 2x. At this point, you would want to distribute the negative or a positive sign. So when we do that, this just is 3x plus 1 plus 2x, and now we're going to combine like terms. I can combine the 3x and I can combine the 2x. So when I do that, I have 5x, and then I am still left with the positive 1, so it's going to be plus 1. So this is our answer here, 5x plus 1. That's what we get when we add f of x plus g of x. Okay, now I'm going to show you an example. Let's say we do f of x minus g of x. And again, just to show you that you may see this written f minus g of x. Okay, so this is going to be 3x plus 1 minus 2x. So we're going to rewrite it without parentheses, distributing that negative sign. So this becomes 3x plus 1 minus 2x. The 3x minus the 2x is just x. So I'm canceling those out. I'm done with those. And then I'm left with a plus 1. So 3x plus x minus 2x is equal to x plus 1. Now I'm going to show you multiplying, and we're not going to do any division. So multiplication is the last operation I'm going to show you. If we have f of x times g of x, that's the same thing as saying f times g of x. And what this is we're going to actually multiply. So we're going to have 3x plus 1 times 2x. And when I do that, I have to make sure that I distribute the 2x to the 3x and to the 1 here, okay? So 2x times 3x is 6x squared, and then 2x times 1 is positive 2x. And this is all you can do for that one there, okay? Now, I do want to add that FOIL seem to have caused some confusion today in class, okay? So in this particular problem we had 3x plus 1 times 2x, right? And we distributed the 2x to everything that's inside. Well, let's say I gave you a problem like 3x plus 1 times 2x plus 1. Okay, very similar problem, but I have this additional plus 1 over here, okay? I cannot simply rely on multiplying the 2x by the 3x and the 2x by 1. I have this additional one out here that I need to use. This is where FOIL comes into play, okay? FOIL is only when you're multiplying, and it only works if you have two terms in the first parentheses and two terms in the second parentheses. And really the only purpose of FOIL is just to remind you that everything gets multiplied, that you're distributing everything, okay? So this is with FOIL, you multiply your first terms. Like this is the first term in this parentheses, and this is the first term in this parentheses. So I multiplied those two terms together. Then I multiply my outer terms together. That's the 3x and the 1. It's the outside term, and that's the outside term. Then I multiply my two inside terms together. That's what this is. And then I multiply my two last terms. That's the last term in that parentheses, and this is the last term in that parentheses. So I multiplied those together. So when you multiply the first terms together, 3x times 2x, you get 6x squared. When I multiply my outer terms, 3x times 1, I get 3x. When I multiply my inner terms together, 1 times 2x, I get 2x. And then when I multiply my last terms together, 1 times 1 is simply 1. So now I'm going to combine like terms. 6x squared doesn't have anything to combine with, so I can cancel that out. Then I've got a positive 3x and a positive 2x, which is equal to positive 5x. So I can cancel those out. And then I'm just left with a positive 1. Okay, so I just want to make sure you understand the difference that FOIL is only when you're multiplying, and it only works if you have two terms in each parentheses. Okay, and really it's just a way to help you remember to distribute. If you can just remember to distribute when you're multiplying, you don't even have to think about FOIL. Let me show you one other example, and this is where sometimes you are going to see a problem. Like if I say f of 4 plus g of 4, okay, which again, that could be written f plus g of 4. Okay, they mean the exact same thing. And so what I'm going to do here is I'm going to plug 4 in for x here, and I'm going to plug 4 in for g here. And then I'm going to add those two together. So this is going to become 3 times 4 plus 1. And I'm going to go ahead and put that in brackets just to kind of keep everything straight. And then I'm adding that to 2 times 4. 3 times 4 is 12, plus 1 is 13, and then 2 times 4 is 8. So when I add them together, I get 21.